welcome as well from my side. I'm so thankful for stopping by here due to the fact that this is the last presentation session right before lunch. Normally, this is a crucial time slot, so thank you very much in advance for your interest. Well, we have a very interesting topic in front of us. Today's session has the title Silane polyurethane-hybrid crosslinkers. This is a technology which we have already introduced 4 years ago at the European Coating Show and 5 years ago during the American Coating Show. And in the meantime, we have further expanded our portfolio and did some further developments. So today we will talk about the latest developments in that crosslinkers sector. Let's focus at first, or let's take a brief look on the agenda for today. The presentation is divided into 3 sections. At first, I want to introduce to you the chemical background of our crosslinkers so that we all understand the background, the raw materials on which these crosslinkers are based on. In section number 2, we'll have a performance check. So here we will talk about the latest products called VESTANAT EP-EF. Will show you some key characteristics and how these crosslinkers can be used. And then we'll proceed to the VESTANAT EP-EF version, silane polyurethane hybrid crosslinker, which is completely based on ethoxy, on an ethoxy silane. So this is a premier. This is the, let's say, newest kit on the block from our side. And the nice thing about this highly active crosslinker is that it's do-it-yourself conform. Yeah, and in the end, there will be a short summary and outlook as well. So let's first imagine a coating system with an extremely high scratch resistance and extremely good durability, somewhat like a diamond. So with these silane polyurethane hybrid crosslinkers, we can't create coatings that are like a diamond, but it's somehow going into that direction. So yeah, I would love to apply such a coating system based on these products, of course, everywhere. Just want to illustrate to you some typical current application fields where those products are in use or could be used at least. So first application field is these crosslinkers can be used for wooden substrates, parquet flooring, or wood flooring in general. This is definitely a fit. These high durabilities and scratch resistances are as well needed when you think about the glossy surfaces of kitchen cabinets at home. It would be nice to prevent these nice surfaces from being scratched due to mechanical influences. Or think about luxury goods, we want to protect them as well, or even our cars. We have a top coat on top of our cars, and it would be nice to have a technology which is even more scratch resistant than current state of the art. With that technology, we are better in scratch resistant and durability. So, besides that, besides scratch resistant and durability, the technology has as well the advantage that and this is especially true for porous substrates like wood, has a flame retardant behavior to a certain extent, and it impregnates your wood structure pretty good. And in parallel, it improves the optical appearance of those wood structures. It pronounces the wood structure quite good if applied as an impregnating coating. So this is quite nice. We will see this later on during the presentation. Yeah, besides that, all the products that we are offering here have a high ease of use, so they can be cured at ambient temperature, so you do not need an oven for curing, and they cure pretty fast. So curing schedules within 1 hour are realizable. This is pretty good. And last but not least, no additional hardener is needed. So this is a technology which crosslinks without polyisocyanates, polyisocyanate-free technology. Here on that slide, you can see how our products are, let's say, yeah, manufactured or produced, or at least the molecule structure can be seen here. So what we are doing actually is we have certain spacers here in the middle, certain backbones, and we end cap these backbones with a molecule which is called IPMS. So we end up with molecules containing urethane structures and these alkoxy groups in alpha-omega position. And these alkoxy groups, or methoxy groups, in case we're using IPMS as a end capping molecule, can react via hydrolysis condensation reaction pretty fast, via methanol evaporation, and build up very dense siloxane networks. And these dense siloxane networks are responsible for achieving these high durabilities and high scratch resistant niveau. So let's proceed to section number 2. So now we understood how our crosslinkers can react at ambient temperature. Now we proceed with the property profiles of our latest developments in the field of VESTANAT EP-EF products. So we have here a product which is called VESTANAT EP-MF203, MF204, MF205. It's that easy, right? So what have we done here? The spacer in the middle of the molecule was changed, obviously. So going from the left to the right side, we used backbones that are a bit shorter, leading to specific properties like a low viscosity here on the right side. We're talking about 150 millipascal seconds and a very high silicon loading. So here we use a lot of IPMS inside of the product. It's very scratch resistant. Then we have here a more flexible type, the MF204. Here the backbone in the middle is a bit longer. We have more urethane structures incorporated, leading to a higher viscosity and a silicon content which is, I would say, on a medium level. And we have further expanded that backbone. We have more urethane structures inside compared to the MF204. Lowest silicon content and a viscosity around 700 millipascal seconds. Okay, we cheated here a bit by using Silane. Otherwise, this molecule would end up with a viscosity of roughly 17,000 millipascal seconds. So these are the products that can be cured at ambient temperature. And now let's take a closer look on the properties that can be achieved in case you are using these crosslinkers in a coating system. What can be said is that from the left to the right side, in case you're using more IPMS or you have a higher loading of silicon, this increases, of course, the niveau of scratch resistance. Also, the flame retardant behavior, chemical resistance, durability, and hardness, all these properties can be, let's say, improved if you use more of these IPMS-bearing molecules, or if you create more of these siloxane networks. So our products can dry pretty quickly. So here we have measured the dust-free time of those products applied alone at a relatively high relative humidity level of 75%. So let's keep this in mind. So here, if MF205 is applied alone, we end up with roughly 120 minutes. Afterwards, you can handle your coated workpiece. Or when it comes to MF203, we're in the range of just 30 minutes. So this is pretty fast. So these are the advantages. We have one drawback here as well that I want to mention. All of these products react via a methanol release. So methanol is going out of the system, unfortunately. For some applications, it's absolutely okay because there you have proper ventilation, there you have all these safety devices, masks, and if you stay below the maximum workspace concentration, everything is fine. But for some applications, for do-it-yourself applications, this is unfortunately a no-go. So this is a disadvantage of those VESTANAT EP-EF products. Okay, how to use these products? What you can do, and this is especially true for wooden substrates, is you can use them alone as a crosslinker and binder. You can use then in combination some solvents to adjust it to a certain viscosity, light stabilizer, and leveling additive, for instance. And then you can apply such a coating, for instance, on wood. We did that here on the right side. So we have coated such a wood panel with that formulation using the flexible type MF205. And here below, we have a reference system, a 2K polyurethane formulation based on HDI trimer, IPDI trimer. And then afterwards, after application and curing at ambient temperature, we scratched above the surface with a cock meter. And here, after the scratching procedure, you see these tiny little arcly scratches that disturbs a bit the appearance of your clear coat. This is not so nice. Here with that technology, you see nothing. This is how it works. So here the inorganic part helps us to gain such a result. Yeah, so this was the 1K approach. Now we come to the 2K approach. This is as well possible. You can just blend the VESTANAT EP-EF derivatives together with a polyol, for instance. We did that here with a acrylic polyol coming from Allnex, a fast-drying one, and used as well solvents, leveling additive, and light stabilizer. And we have conducted an anti-graffiti test with such a formulation. So first picture here shows us a reference system, again, 2K polyurethane formulation, IPDI trimer-based, HDI trimer-based. And we put on top of that clear coat graffiti coatings, a yellow one, a red one, and a green one. And after a certain period of time, we washed, or we tried to remove that graffiti by using just an ethanolic solution. And it can be said here, it's quite obvious on the right side, after this cleaning procedure, the clear coat was heavily attacked by the solution. We have here a turbid optical impression. This does not look that nice. And we were not able to remove all of these graffiti coatings, unfortunately. With such a formulation, it's possible to remove all of the graffiti. So also the green one was not an issue here. And moreover, the clear coat was not attacked by the solution. So the clear coat is more durable. And with a high loading of VESTANAT EP-MF203, so approximately 50% in such a formulation, even this yellow graffiti coating does not adhere anymore on the surface. So you have some sort of repellency effect, easy to clean effect, anti-graffiti behavior. So this is also as well a quite nice effect of that technology. So the tendencies are always the same in such a 2K polyurethane formulation. If you combine the polyol together with EP-MF, if you increase the dosage of VESTANAT EP-MF, you will reduce the drying speed, of course. You will increase the scratch resistance. The durability will be higher with a higher loading of these IPMS-bearing molecules, and the hardness will be as well higher, or the opposite way around. The flexibility momentum will be reduced to a certain extent. So, but again, we have the drawback of that methanol release. So for some applications, that is okay. For some applications, it's not. And we thought about it would be nice to have these kind of products available also for those applications, for do-it-yourself applications, or other applications where you do not have these proper ventilated areas. So that was the reason why we have invented the VESTANAT EP-EF 201. This is the first fully ethoxy-based crosslinker, do-it-yourself conform. So what are we doing here? Instead of using IPMS with methoxy groups, we are using now, exactly, thank you very much, IPES, it's that easy. So we are completely methanol-free, and we can convert here as well this isocyanate group with certain spacers, certain backbones. So this is how we do it, but it was quite complicated to find let's say, appropriate catalyst package because we were looking for a catalyst which has a low toxicity momentum, which is available, which is low in price, and which can ensure a curing of an ethoxysilane, which is then comparable to a methoxysilane. Normally, ethoxys are roughly 10 times slower compared to methoxy groups. So it was pretty hard to find an active catalyst here because, of course, the goal was to ensure same curing than with a methoxy-based crosslinker. It took us years and a lot of catalyst screenings, but in the end, we think that we succeeded. So we have submitted now patents and found the EF201 zero methanol emissions do-it-yourself conform. And when we take a closer look here on some of the properties and compare VESTANAT EP-EF201 with our EP-MF203 with the shortest backbone in the middle, then we see that we can end up with more or less similar dust-free times of measured at 23 degrees C, 50% relative humidity level. And here it can be adjusted depending on how much catalyst is inside of the product. It could be faster, even faster. We can bring it down to 20 minutes, or we can make it also a bit slower, so then more in the range of 120 minutes. So it's adjustable here. That's as well a nice beneficial aspect to mention. Yeah, what about the pendulum hardness? After 1 day, we reach roughly 100 pendulum seconds, so more or less completely equal. The viscosity is incrementally higher due to the fact that the chain is a bit longer. The ethoxy groups are a bit longer than compared to the methoxy groups. So, but this is just an incremental effect, I would say. When it comes to chemical resistances here, for instance, we have measured the MAK resistance via double rubs. We are above 150 double rubs in each case. So, yeah, it's a nice crosslinker and completely comparable to the methoxy-based crosslinkers, because what happens is methanol will be released or ethanol will be released, and the remaining network, the siloxane network, is then the same. So you have comparable properties in the end. Yeah, there exists 3 ways to optimally use EF201 currently. So one way is what we have seen before. It can be used alone, especially on wooden substrates, can be used alone, or as well in combination with appropriate polyols. This is as well possible, comparable to the VESTANAT EP-MF products. But we have a third option available. That option was not available with EP-MF. So now we are able as well to blend our molecules, our EF molecules, together with polyisocyanates. And this is quite nice because you have then 2 networks in the end. One network is a urethane-based network coming from the polyisocyanate and acrylic polyol, and you have the other network coming from the alkoxysilane, the siloxane network. And here you can really adjust the ratio of the polyalkoxysilane freely. So you can adjust the system to your needs, I would say. Yeah. Outstanding appearance enhancement can be achieved on wood substrates. We have here a picture of different types of wood, nut, oak, ash, beech, and so on. So these untreated wood surfaces look a bit grayish, and of course these wood substrates are porous. And in case we apply VESTANAT EP-MF or VESTANAT EP-EF, we seal the upper layer of the substrate, and we can enhance, as I said before, we can enhance the appearance of the wood. We pronounce more these wood characteristics here, so it's a nice optical impression. And you just need, I don't know, 1 micrometers up to 5 micrometers coating thickness here. So this is pretty nice, and you, of course, can achieve all these other beneficial aspects like improved chemical resistance, fast drying, and so on when you use these crosslinkers in such a application field. And by the way, we see no difference here between VESTANAT EP-EF and VESTANAT EF. So it's a pretty equal result here, I would say. Same optical impression. So that was it about the VESTANAT EP-EF derivative, our newest kid on the block. Let's proceed to the summary and outlook. To sum it up, the latest VESTANAT EP-EF products, as we have seen before, exhibit very fast curing cycles at ambient temperature. They can, with those crosslinkers, it's possible to formulate coatings with a high durability, with an anti-graffiti behavior. And when it comes to wood structures or wood surfaces, we can have very good appearances, or at least we can improve the appearance of the wood dramatically. So, the new VESTANAT EP-EF 201, highly comparable to VESTANAT EP-MF 203, but ethoxy-based and do-it-yourself conform. So in case you're interested in testing such a product, then please come to our booth. You can register yourself there, and then we will hand over to you a sample in case you're interested in it. Yeah, the outlook is as follows. So we start here with the most rigid material, the material with the shortest backbone in the middle. And of course, we want to expand there the portfolio as well. So the goal is then in the future to have also these more flexible versions available. So it could be in 2 months, 3 months, 4 months from now on that we will have an EF 204 or EF 205 available. So perhaps products that are more compatible to these solid substrates like metal, for instance. Yeah. If you need further information for this technology, we have tons of literature available at our booth. You are always welcome to visit us. We are located in Hall 7A, booth 323. Or, as well, we are there for you. So my colleague, Mr. Dr. Guido Streukens, he will be there tomorrow. He's an expert in that technology, and you can, make an appointment with him, or I will be there for the whole ECS until Thursday. Or in case you can't manage it to come to our booth, then you have here the contact coordinates. Please write an email or call. We are there for you for Europe. For NAFTA, our colleague, Mr. Dr. Corey King, is responsible for the technical service support and would be happy to get in contact with you as well. So, that's it from my side. I hope we are on time, more or less. So everybody is hungry now. Yeah. So have we still time for some questions? No, not really. Okay, then I would suggest to postpone the question and answer session. Please, if you have questions, come to our booth, or now afterwards, after the presentation, I will be there for you. So thank you very much again for your interest and for your time. Wish you a nice day, and hopefully see you soon. Bye-bye.